Morning to all. Very good morning to all. Great welcome to 2021. Happy New Year once again to all
Same to you, sir.
students.
Same to you.
Wish you
Uh,
this sir.
yeah, thank you so much for all. I'm going to share the file now. It's one, I hope, wonderful year for all of you. I know that the year that we passed away, it was really, pandemic. It was really, we faced a lot of issues, but still, we learned a lot of technology. It was really wonderful. I mean, to learn for you and for us, new technology, which is very important for the country to develop. Okay. I hope this will help for the entire country to move forward to reach the world countries, which are topmost countries in the world. So before we were thinking that how can we move into the online? Now it is possible to move the online, and we made it. I mean, everybody was thinking that how can we reach the student? Yes, we were reaching the student. We were reaching everybody in the world with the online connection, virtual platform. I mean, previously only America was the only one country was was able to reach the online successfully they completed. But now I would say into the most of the countries they trained up and they have been doing the online jobs. They have been doing the softwares are working online. Most of the people they started to work from the home, and the students although almost they reach to learn some technology. I mean, it is very important. I mean, as you know, the technology, the online platform would really help it a lot to learn the blended learning teaching. The blended learning teaching is the one where you are using the digital technology, where you are using the animation technology, where you are easily watching the YouTube connections related to our subject. But when you go to the classroom platform, we may not have that facility to show all the technology or nanotechnology, whatever the technology available in each subject. And this pandemic helped a lot to learn most of the stuff, and this also helped a lot to reach any faculty member in the world with just simple way of a virtual platform. Before, it was really tough time to convince them to come to offline class. Now we have been conducting the international webinars, national webinars, state level webinars. Really wonderful, I would say. A great welcome. I hope it's a really wonderful year 2021. We hope we use both offline and online technology to reach you guys. We hope that we make you happy in terms of the teaching, in terms of everything. So that's my beginning class of the 2021. I hope everybody really excited to see a lot of things in the 2021. All the best. I hope you will reach your goals soon, with your great effort. Don't stop your effort and completely focus on online classes. If the classes will start offline, you can join it. But until that time, don't miss the online classes. Really, you also use this online platform, learn, use the YouTube videos, and search the topics, learn more. Don't limit your subject, don't limit to notes only. You can explore like anything, you can reach out like anything. Don't ask only limited notes. Don't You have enough knowledge in the online each subject. You just need to go and find a lot of information in online. Okay, whatever we teach, definitely it's limited. I mean, for a talented student, you have enough knowledge, you have enough sources, you have enough material online. Go and find out, watch it, learn technology. You are the one, the future scientist. You are the one, future engineer. You are the one, future administrator. You are the one, the world making person. So don't limit yourself. Explore, use online, use phone, use technology to to be a smart student, to be a smart member in the society, and train up the teach your friends how to use the technology. Okay, I think we have covered last time variable mass. example, it was really wonderful rocket. We took it, variable mass system, how the motion will change, and we have shown that we have took the Newton's second law, and where we have considered the mass is variable because the fuel is changing, so mass is variable, velocity is changeable. So minus comes dm, which is actually ejected mass. So m plus dm, v plus dv plus u is the velocity of the gas which we lose from the rocket. Minus indicate the mass of the ejected gas. And we use simple basic, multiplication, and we got dp, change in momentum. We got it. That is mdv plus vdm minus, udm. From that, we have got the F external force equal mdv by dt minus v real dm by dt. Here, if the external force is zero that we are providing for the rocket, and then we were also proved that mdv by dt is equal to v real dm by dt, which is the thrust of the rocket, which is the force which lift the rocket to upward. And rocket can accelerate even no external force act on it, hence momentum is conserved. And now the system is, we are very important. We are in the, this you can see multi-stage rocket. What is that? What stage is multi-stage? How rocket works? I'm just showing here GSLV rocket, which was, ISRO, which was made by ISRO scientists. Really wonderful to see this GSLV, and which has a, different stages. When you are, making the rocket, definitely when you are making the satellite, you have to provide the different. You have to provide the different stages where it loses. Finally, the one which is only which is only revolving around the earth. Okay. GSLV is a kind of like a geo satellite launching vehicle. Geo satellite launching vehicle, which means what? Geo means earth. It gives the information about the, అంటే మన ఎర్త్ చుట్టూ తిరుగుతున్నప్పుడు దానికి సంబంధించిన మనకు అట్మాస్ఫియర్ కానీ కమ్యూనికేషన్, టెలివిజన్, ఫోన్, మొబైల్ టెక్నాలజీ, వీటికి సంబంధించిన కమ్యూనికేషన్, శాటిలైట్ సిగ్నల్స్, వాటికి సంబంధించిన అన్ని కూడా మనకు శాటిలైట్స్ నుంచి వస్తాయి. ఇన్ ఫ్యూచర్, వాట్ ఈస్ ఇంపార్టెన్స్ ఆఫ్ రాకెట్ సాటిలైట్స్? డెఫినెట్లీ నో మోర్ టవర్స్ బెటర్. ఇప్పుడు మనం జియో టవర్ కావాలి, బిఎస్ఎన్ఎల్ టవర్ కావాలి, ఐడియా టవర్ కావాలని చూస్తున్నాం. వెన్ యూ గో టు ది విలేజెస్, యూ ఆర్ సేయింగ్ దట్ సార్ వీ డోంట్ హ్యావ్ ద సిగ్నల్స్ ఇన్ మై మొబైల్, ద మొబైల్ డేటా ఇస్ నాట్ వర్కింగ్ అంటే సిగ్నల్స్ లేవు. దానికోసం ఏం చేస్తున్నాం? what scientists are doing, you know that the scientists have been doing that. They are just making the satellite which revolve around the, మన కంట్రీ పైన ఉన్నటువంటి, పైన తిరుగుతూ ఉంటాయి, ఎంటైర్ కంట్రీలో సిగ్నల్స్ ఇవ్వడానికి హెల్ప్ చేస్తాయి. ఇప్పుడు అమెరికాలో దే డోంట్ హ్యావ్ టవర్స్, దే డోంట్ హ్యావ్ ఇట్లా జియో టవర్లా ఇలాంటివి ఏమి ఉండవు టవర్స్. మన దగ్గర ఒక దగ్గర రాకపోవడం, ఒక దగ్గర అలా ఉండదు బిడ్డ. ఎంటైర్ కంట్రీలో సిగ్నల్ లేని చోటు ఉండదు. సో దట్ ఈస్ వాట్ టెక్నాలజీ నౌ ఇన్ ఫ్రంట్ ఆఫ్ అస్. యూ హ్యావ్ ద సైంటిస్ట్ ఆల్రెడీ స్టార్టెడ్ టు డెవలపింగ్ దాట్. సో అలాంటి సాటిలైట్స్ మనకు డెవలప్ అయితే మనకి ఇట్లా ఒక డౌన్లో ఉంది, హిల్ పైన వెళ్ళాల్సిన సిగ్నల్స్ కోసం పరిగెత్తాల్సిన అవసరం లేదు. సో దిస్ ఇస్ వాట్ వీఆర్ లుకింగ్ టెక్నాలజీ. ద టెక్నాలజీ వీ నీడ్ టు యూజ్ ఇట్ టు ఫర్ ద ఇంప్రూవింగ్ నాలెడ్జ్, నాట్ ఫర్ ద డ్యామేజింగ్ అవర్ సెల్ఫ్. టెక్నాలజీని వాడి యూట్యూబ్ వీడియో చూసి డ్యామేజ్ చేసుకుంటే లైఫ్ అంతా మీది డ్యామేజ్ అయిపోతారు. యూజ్ ద టెక్నాలజీ టు ఇంప్రూవ్ యువర్ స్కిల్స్ in terms of language, in terms of technology, in terms of your personal skills, personality development, everything. ఆ విధంగా యూజ్ చేసుకుంటే మీరు లైఫ్ టర్న్ అవుతుంది. సో హియర్ మల్టీ స్టేజ్ రాకెట్. వాట్ ఈస్ అ మల్టీ స్టేజ్ రాకెట్? యూ కెన్ సీ హియర్ I can so let me go for the first. You can see, let me go for down to the, okay. So first what you do there, you can see this is the satellite we make it. Then here you can see ISRO is the name is there, GSLV, Geo Satellite Launching Vehicle. And you can see first what they do, strap on boosters. So booster is a kind of giving the energy. So what is that? The GSLV uses 4 liquid strap on motors. So what is that? They use the 4 liquid strap on motors. The strap one are powered by one Vikas engine each, and along with solid rocket motor core of the first stage provide enormous thrust to the launcher. The first trap, what it does, tell beta, it gives the energy. It gives the energy boosting. Okay, it has a four liquid drops. It's a fuel like a petroleum, like a liquid gas. Okay, so there are one by one Vikas engine by each. Like there are four one are there. Okay, the first drop, which is actually it gives the start of energy, start of thrust. పైకి వెళ్ళాలంటే ఏం చేయాలి ఫస్ట్ it should go right, it pushes up. So startup energy is, we call it startup boosters. What are called startup booster? What do you call it? Strap on boosters. Strap on boosters. What they have it? They have uses four liquid strap and motors. And the strap ons are basically powered by one because engine each. So this is the which helps the to provide the enormous, what is that? Enormous thrust to the launcher. Starting la launch ఇక్కడ ఉంటుంది బేటా, ఇది రాకెట్ పైకి ఎలా ఉంటుంది, లాంచింగ్ వెహికల్ ఉంటుంది, దానికి మనకు we provide that. This is over now. Now you understand there is a one thing required for the satellite, which is stratum booster. This is the one which gives the energy to lift up satellite. First stage, second, this is called first stage. So what is this actually, tell me? So what is that? The first stage of GSLV is the ignited and fired. అంటే మంట 4 seconds ignited అని తెలుసు కదండి, మంటలు వస్తాయి ఫస్ట్. ఇది ఎప్పుడైతే when it goes up immediately మనకు ఫైర్ వస్తుంది, ignited. 4 seconds after the ignition of the force drop, one after one, ensuring their full functionality. This is required in order to extract maximum thrust out of the initial stages. The solid core of the first stage burned for 100 seconds, while the strap on one continue to provide the thrust for the another 50 seconds. So this is a very important stage for the successful launching of the GSLV. First stage low, we provide the some kind of thrust in terms of four liquid strap. And here what we do, like once it started, there is a first ignited 4 seconds fire. There is a ignited, JSLV is ignited 4 seconds after the ignition of the force trap. ఇది అయిపోయిన తర్వాత ఇమ్మీడియట్ గా మనకు ఫైర్ వస్తూనే ఉంటుంది. ఓకే, అది అప్పుడు ఫంక్షనాలిటీ వస్తుంది, ఫంక్షన్ పనిచేస్తుంది, ఇట్ వర్క్స్ వెల్. అండ్ దిస్ ఈస్ రిక్వైర్డ్ ఇన్ ఆర్డర్ టు ఎక్స్ట్రాక్ట్ maximum thrust. The second first stage లో what it get it, after this it get more thrust to go up. And the solid core also there. Then this, what is there extra? Solid. Liquid is over, then there is a solid core is there. Solid core, the first stage burns 100 seconds burn avutune untadi. That also provides the thrust to the launch to go upward. Okay, is it clear? So now I can see that let me. So you can see now the first stage is over, startup and booster is over. First stage లో ఏమైంది, ఫస్ట్ స్టేజ్ లో లిక్విడ్స్ యూజ్ చేస్తాము టు గెట్ ద మోర్ thrust for the launching vehicle. ఫస్ట్ స్టేజ్ లో దిస్ ఇస్ జీరో స్టేజ్, యూ కెన్ థింక్ అబౌట్ ఇట్. అంటే ఈ భూమి మీద ఉన్నప్పుడే ఇది ఫస్ట్ స్టేజ్, ఫైర్ వస్తుంది, దాంతో ఇట్ గెట్ మోర్ థ్రస్ట్ పైకి వెళ్ళడానికి. సెకండ్ స్టేజ్ ఆల్సో యూ హ్యావ్ టు లర్న్. So zero stage, first stage, seconds. In the second stage, what happened? The high thrust, okay, hypergolic liquid propellant Vikas engine, never improved version with a higher chamber pressure is used here. It is activated 156 seconds into the flight. So this is the second stage where we use this liquid again here to get the higher thrust upward direction, and especially we provide the very high chamber pressure. Okay, so it is how many seconds are there? 156 seconds. How many minutes beta? 60 by 60, right? So 20 minutes something, right? So how much? 20 minutes. Not sorry, not even 20 seconds, right? 2 minutes something. 2 minutes something. So 2 minutes, kind of like its pressure is very high. It is activated for 2 seconds. Okay, and moving into last stage, third stage. Sorry, fourth stage also there, but that's we don't call that fourth stage. And third stage, you can see that. And what is going cryogenic upper stage? This is see the first stage liquid unnadi tarvata we use zero stage lo liquid tarvata first stage lo a solid, second stage lo we use low pressure, right? uh, and also in third stage lo what we are doing again, cryogenic 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 upper stage of GSLV import high velocity. This is the stage where the launch get vehicle get more velocity, okay, more momentum, okay, to the payload and detaches at the it remove one of the part, the down part which you have seen in video, right? One of the part will remove this third stage. Okay, now that will be directed towards the sea. ఓ సీల పడేటట్టు చేస్తాం. Okay, this high velocity characterizes of the geosynchronous transfer orbit. Once the spacecraft reaches the like this eccentricity means there is a orbit, right? Once it reaches this orbit, it perform like a very high speed, and it performed the burn using its onboard engine to circulate its orbit. Once the orbit లోకి వెళ్ళేంత వరకు ఎనర్జీ వచ్చిన తర్వాత ఇందులోనే తిరుగుతూనే ఉంటుంది. So that has kind of like it's some engine they put it inside. That engine helps the fuel to circulate, revolve around the orbits. So last payload fairing at a distance of 3-4 miles, the payload fairing on GSLV is wider than the rest of the launcher. The fairing provides aerodynamics efficiency and shield the payload from the mechanical damage during the atmospheric phase of the flight. So this is kind of like helps launcher. It also provide the like mechanics, like provide the aerodynamics efficiency, shield also top shield, okay, from the damage. Suppose when you go high speed and there is a surface damage, right? And this is a kind of helpful, okay, not to damage. And these are sometimes if they ask 4 marks question, can you explain the multi-stage rocket? You just need to write it a very bullet point, very basic bullet points, okay. Don't the first one is basically, so let me summarize this 4 marks question. Don't worry, it just first zero stage we need a boosters to give the initial impulse with how do we get the impulse, how do we get the thrust? With the help of 4 liquid strap on the motor. So that helps to get the initial impulse or initial momentum or initial thrust. Okay, the first stage basically it's kind of like a fire will happen 4 seconds. That will actually after this 4 straps that is over, then there will be 4 seconds fire. Okay, full ignition will come, it just launch, it just go upward. Okay, and this is a kind of like maximum thrust start, like after that solid core also start burning. There is a solid core, yeah, after liquid there is a solid core is there, that will start burning, and 100 seconds, almost like more than 1 minute, this is a burn, like fire will come. Okay, and then this is a stage where you will get, where the launch will get more thrust, ఎక్కువ బాగా thrust పైకి పుష్ చేయడానికి. సెకండ్ స్టేజ్లో మనకు మళ్ళీ అగైన్ లిక్విడ్ ప్రొఫైల్ అనేది ఉంటుంది, హైపర్. సో ఇయర్ హై థ్రస్ట్ వస్తుంది సెకండ్ స్టేజ్లో. Oh, here again they apply the liquid. So here in this stage the pressure is very this number, what is the high pressure is there, and it is like more than 2 seconds it activated. After after 2 seconds, after 2 minutes, it started activating second. So they set up all the program what time it should start. Third stage also there, which is actually again high velocity, and here it helps to detaches one of the part detaches in third stage, and the fourth one is it helps to shielding. It helps like a shielding, not to damage the vehicle. So this is like don't you can write it just headings and write something. You get 4 marks. Okay, is it clear, Nana? Students,
Sir,
just you can write headings and get four marks question. Here you can see I was trying to so what rocket I was trying to explain here. It lightens the rocket and it can go further. What is the main advantage of the multi-stage rocket? So what is the advantage of multi-stage rocket? So rocket compared to the single-stage rocket. This is a question. So if someone asks you what is the advantages of multi-stage rocket compared to the single-stage rocket, the main advantage of multi-stage rocket is that total weight of the rocket is greatly reduced. So when you keep the multi-stage rockets, so the weight of the rocket, the weight of the rocket reduce a lot. So compared to single rocket also, single stage rocket also, you need to give all the sort of energies, liquid, solid, core, everything. But when you keep the multi stages, you don't need to keep everything again. The base is enough. So by making the multi-stage rockets, what we can get it is we can reduce the weight basically. So let's go for the next. So what is the conservation of momentum beta? As you all know that if external force is equal to 0, dp by dt is equal to 0. From here, dp is equal to 0 and p is equal to constant. This is what. So if someone asks you what is the conservation of momentum, so conservation of momentum can explain many ways. If the external force acting on the system is equal to, if the external force acting on the system is equal to 0, then its linear momentum is equal to constant. According to Newton's second law, external force equal to 0, rate of change of momentum is 0, momentum is 0, change in momentum is 0, momentum is constant. Okay, so or before collision, the total momentum of the before collision must be equal to total momentum of the after collision. Also, we can say that conservation of momentum, pi is equal to pf. So initial momentum must be equal to final momentum. Here you can see that in an isolated and closed system, the total momentum of the system remain constant because here no f is equal to 0. In isolated system, no external force is right, no external force. Closed system, no mass enter, leave it. So the linear momentum of each colliding body may change. The total momentum of the system cannot change. So basically, any closed loop, any isolated system, the total momentum is equal to constant. Okay. Again, this is also kind of like a 4 marks. Sometimes they will ask, okay, define the conservation of momentum, conservation of energy. Conservation of momentum is simply the momentum before and after collision same, or if the external force equal to 0, the external force equal to 0, which is acting on the system, then the system momentum is constant. Is it clear? Yes, Nana?
okay, sir.
Momentum constant అయితే దాన్ని ఏమంటారు? Conservation of momentum. ఓకేనా? ఇఫ్ ఎనర్జీ కాన్స్టెంట్ అంటే కన్జర్వేషన్ ఆఫ్ ఎనర్జీ. అంటే బిఫోర్ కొలిజన్ ఆఫ్టర్ కొలిజన్ ఎనర్జీ కాన్స్టెంట్ సేమ్ ఉంటే దాన్ని కన్జర్వేషన్ ఆఫ్ ఎనర్జీ అని, మొమెంటం కూడా బిఫోర్ అండ్ ఆఫ్టర్ సేమ్ ఉంటే దాన్ని కన్జర్వేషన్ ఆఫ్. So I just trying to you can see here when no external force is act on the system, and force లేదు, when no external force act on the system consisting of two objects that collide each other, రెండు కూడా కొలైడ్ అవుతున్నాయి అనుకుందాం. Okay, so the total momentum of the system remain constant. At a before collision, before momentum, after momentum should be equal to same. So you can see that f into delta t. So f is equal to delta t p by delta t. Cross multiply చేస్తే ఎంత వస్తుంది? F dt is equal to delta p, right? So this is equal to PF minus PI. If this is equal to 0, PI is equal to PF. That's it. So for isolated system, basically both momentums are same. The total momentum before collision will be equal to total momentum after collision, after momentum. Right. So you can also see here the momentum. You can also write it like M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. అంటే momentum PI is equal to PF. సో ఇది ఒక ఆబ్జెక్ట్ ఇది ఒక ఆబ్జెక్ట్ వాటి యొక్క momentum సమ్ చేస్తే దట్ ఈజ్ ఈక్వల్ టు momentum ఆఫ్ ది ఫైనల్. ఓకే, ఇస్ ఇట్ క్లియర్?
Yes, sir.
రైట్. యూ జస్ట్ నీడ్ టు కైండ్ ఆఫ్ కాన్సెప్ట్. ఏం టెన్షన్ పడకుండా తెలుగు మీడియం వాళ్ళకు ఇక్కడ ఏం అర్థం కాదు. అంటే మనము ఒక సిస్టమ్ మీద ఒక ఫోర్స్ అంటే బలము ఫోర్స్ ఎప్పుడైతే జీరో అవుతుందో అప్పుడు ఆ సిస్టమ్ మూమెంటం అనేది అంటే రేఖీయ ద్రవ్యవేగం అనేది మనకి ఏమవుతుందంటే కాన్స్టెంట్ గా వచ్చేది. ఓకే, someone is talking. I don't know whether it's question. So I mean, I can also see that collisions 1D moment. Sometimes they're going to ask like explain with the kind of like a basic collision problem. So you need to write it. This is a ball M1. That's velocity V1. It's another one M2. It's moving this direction V2. This is a positive direction. And after collision, you can think about it. It's coming this way. It's coming this way because this mass is M2 is greater than the M1. So M2 is greater than the M1 case. So it is going this direction and this ball is coming backward. So here the coordinate axis and define the velocity with respect to each other. It is convenient to make your axis coincide with one of the initial velocities. So diagram you can see here. So this is before collision, this is after collision. Yeah, I mean, this is already M1. I told you, right? The two momentums, are equal. Before collision must be equal to after M1 V1 plus M2 V2. That is I kept it. M1 V1 plus M2 V2 FF. So F indicates final, I indicate initial. The total momentum before collision must be equal to the total momentum after collision. I mean, conservation of energy. What is the conservation of energy, beta? So in the elastic case, so in a conservation of energy also important. Sometimes like ask if the collision is elastic, so what happened in kinetic energy initial equal to kinetic energy final, right? The kinetic energy of the system before and after collisions are same. So then the energy is conserved and momentum is also conserved. So momentum and kinetic energy are conserved before collision or after collision. They are same. So we call it conservation of energy, right? This is only applied to perfectly elastic collisions. But inelastic collision, this is not equal to 0. సో ఎలాస్టిక్ అంటే స్థితిస్థాపక అభిఘాతాలకు మాత్రమే మనకేమవుతుంది బేటా కైనెటిక్ ఎనర్జీస్ ఆర్ ఈక్వల్ ఇనిషియల్ అండ్ ఫైనల్ అండ్ మొమెంటల్స్ ఆర్ ఈక్వల్. బట్ ఇన్ కేస్ ఆఫ్ ఇన్ఎలాస్టిక్ అంటే అస్థితిస్థాపక అభిఘాతాలకి దిస్ ఈజ్ నాట్ ఈక్వల్ టు 0. KI not equal to KF. So when you are looking this inelastic collisions, which means what are the inelastic collisions? One ball is here, one ball is here. After collision, what happened? They move together. So this is called inelastic collision. So elastic collision, after collision, they move separately. Inelastic collision, they move together. Like when you fire a bullet, what happened? Bullet వచ్చి మన బాడీ తగిలిందనుకో బాడీలోకి వెళ్ళిపోయింది బుల్లెట్ ఇద్దరు కలిసి కింద పడిపోతారు. సో ఇన్ దిస్ కేస్ ఇన్ఎలాస్టిక్, అర్థమైందా? సో బుల్లెట్ వెళ్ళి బాడీలోకి వెళ్ళిపోతుంది కాబట్టి బాడీ బుల్లెట్ ఇద్దరు కలిసి మూవ్ అవుతారు, అది ఇది. సో అప్పుడు ఏమవుతుందంటే m1 u1 ప్లస్ m2 u2 ఈజ్ ఈక్వల్ టు m1 ప్లస్ m2 v అవుతుంది బెట, ఎందుకంటే కామన్ వెలాసిటీ. ఆఫ్టర్ కొలిజన్ దే మూవ్ టుగెదర్ కాబట్టి దే హ్యావ్ సేమ్ కామన్ వెలాసిటీ. ఓకే, సో కన్జర్వేషన్ ఆఫ్ momentum, conservation of energy are satisfied in case of elastic collisions. But in elastic collision only momentum is conserved. ఇన్ఎలాస్టిక్ అంటే ఇట్లాంటిది ఇందాక చెప్పాను కదా, దీనికి ఏంటి ఓన్లీ మూమెంటమ్ ఈస్ కన్సర్వ్డ్ బట్ కైనెటిక్ ఎనర్జీ ఈస్ నాట్ కన్సర్వ్డ్. ఇస్ ఇట్ క్లియర్?
Yes,
Student,
sir.
you can ask me to stop also anytime. It's no objection from my side.
Clear, sir.
అంటే ఏం లేదు బట్ ఇదంతా ఇంటర్మీడియట్ నేర్చుకుందే కాబట్టి ఐఎమ్ జస్ట్ గోయింగ్ లిటిల్ ఫాస్ట్. I don't know whether you learn intermediate, but I'm assuming if you have done very good job in our intermediate, definitely you have gone through all this stuff. But here also they can ask questions. We have, I have written here. This, so this is one of the example for the 1D. అంటే collisions ki this is okay. One dimensional versus two dimensional. సో 1 dimensional వర్సెస్ 2 dimensional ఏమవుతుందో చూస్తున్నారు ఇక్కడ. సో మనకు 2 డైరెక్షన్లో ఇప్పుడు ఒకసారి ఇక్కడ చూసినట్టు అవుతాయి మీరు. ఇది ఐడియా ఉంది, ఏ గేమ్ చెప్పండి? వాట్ ఈస్ దిస్ గేమ్ నేమ్?
పూల్ గేమ్ సార్, పూల్ 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 8 బాల్ పూల్.
ఓకే, సో ఇక్కడ ఏం చేస్తాం, దీంతో డైరెక్ట్గా హిట్ చేస్తే అందులో పడిపోవాలి. సో ఇన్ దిస్ కేస్ here it's a 2-dimensional also, right? It may not go, we are targeting this one, no? Right? We are targeting this guy. It may go this way, it may go this way, you don't know. But the way you hit it is, if you hit this side, it will go this side. If you hit this side, this will go this side. So this has become 2D, right? So ఇక్కడ మనకు ఇక్కడికి వచ్చిన తర్వాత 2D డైమెన్షన్కి వెళ్ళిపోతుంది 1Dలో చేస్తే. సో మనకు 1D 2D 3D 3 ఉంటాయి. ఓకే, 1Dలోనేమో ఒకటే డైరెక్షన్లో వెళ్ళిపోతుంది. ఇక్కడ బాల్ హిట్ చేస్తే ఇదే డైరెక్షన్లో పోతే 1D అంటారు. ఇఫ్ ఇట్ గో 2 డైమెన్షన్లో వెళ్ళిపోతే అప్పుడు 2D అంటారు. 2D మీనింగ్ 2 డైమెన్షన్, రెండు దిశలలో వెళ్తుంది. ఒకే దిశలో వెళ్తే 1D అంటారు. 2D 2 డైరెక్షన్లో వెళ్తే 2D అంటారు. 3 డైరెక్షన్లో వెళ్తే 3D అంటారు. దట్స్ ఇట్. సో యూ నీడ్ టు అండర్స్టాండ్ వాట్ ఈస్ ద how it goes. Example, write examples 1D 2D 3D. So let me just stop. I don't know why it's coming like this. Did you fill the attendance beta? Let me post again. Just posting. Going back. Right. So you can see here what is the 2-dimensional collisions. Here you can see 2-dimensional collisions. So what is here? Tell me. So I'm telling 2D collisions. So here the ball is here, another one is here. When you hit this guy, it's going 2D direction. It's going 2D, and each one also here it's moving. This direction means it has a vertical direction, it has a horizontal direction, right? So with a theta, so definitely it has a 2-dimensional. The ball is the first ball 1 and 2. 1 is going 2D and 2 is also going 2D. It's going forward and height. So vertical వెళ్తుంది, ఫార్వర్డ్ డైరెక్షన్ వెళ్తుంది, రెండు డైరెక్షన్లో వెళ్ళిపోతుంది కాబట్టి XY డైరెక్షన్ రెండిట్లలో. దట్స్ ద రీజన్ వి రిజాల్వ్ ఇంటూ కాంపనెంట్స్. థీటా ఉంది కాబట్టి V1 వెలాసిటీ కాబట్టి V1 cos theta, V1 sin theta. In this case also V2 cos theta, V2 sin theta. So this is, we call it as a 2D. Here you can think about 1D. So I am also writing equations here. M1 V1 Ix, we get X direction. M2 V2 Ix. M1 V1 Fx final. M2 V2 final X. Similarly, and I can write vertical direction. This is horizontal direction. This is vertical direction. M1 V1 Iy, M2 V2 Iy. So this is the final velocities. right? So two-dimensional collision, the momentum is conserved in all direction. Ante oka momentum conserve oka direction lo aindante, so it should also momentum is conserved in all direction, x direction lo and y direction, both direction lo it should satisfy. Okay, the momentum is conserved in all direction. If it is two-dimensional, it conserved in all two-dimensional. If it is three-dimensional, it also conserved in three directions. Okay, so use the subscripts which I used here, identifying the objects, indicating the initial and final is the I do F. Elastic components also cos theta and sin theta. Cos theta is the horizontal component, sin theta is the vertical component. If the collision is elastic, I mean, you can think about both. Use the conservation of kinetic energy as a second equation, right? If the collision is only inelastic, you don't have the kinetic energy term because it's not equal to zero. So with the collision in elastic case, both momentums are equal, kinetic energy is also equal. But in case of moment inelastic, అంటే అస్థితిస్థాపక విఘాతాలకు, this is not equal to zero. Okay. Yeah, you can see that. So you can see, I mean, indicator. I'm trying to say here, show here. So X indicates, X, Y indicates X and Y directions, vertical and horizontal direction. You can also see how they are going. So one F, one I initial, one F final. Two second one, two F final, two I initial. So lastly, one of the elastic scattering. What is the scattering? So that is over beta. Rocket collisions 1D, 2D. I'm going to show you that how can we do that. But I think rocket elastic scattering also important. We have a kind of like a very basic elastic scattering. So you can see gold foil experiment. I think we have 10th class లో చదువుకుని ఉంటారు. This is a gold foil. అంటే gold foil అంటే thin sheet బెట్ట.
Rutherford model.
ఎస్ బెట్ట కరెక్ట్, రూథర్ మోడల్. సో ఏం చేస్తాం ఈ షీట్లో మనకి ఏం వై వీఆర్ డూయింగ్ దిస్ టు డిటర్మైన్ ద న్యూక్లియస్ ఉందా లేదనేది ఫైండ్ అవుట్ చేస్తాం. అంటే వెదర్ ద ఆల్ఫా పార్టికల్, దిస్ ఇస్ ద ఆల్ఫా పార్టికల్ సోర్స్. So the alpha particle go and hit this gold foil, and if it directly go to the nucleus, I mean he found that it is not directly going and hit the nucleus. It's going like a ways, like deviating from the centers. So in that case, it is there is some kind of positive charge is there, because alpha is a positive, and if the nucleus is also positive, it doesn't hit the positive, right? It just go deviate from that. So that is the reason I think Rutherford did that experiment and proved that nucleus has a positive charge, which is actually neutron and proton inside, and the electrons are revolving around the nucleus. Before that, no scientist was actually discussed about whether the positive, negative. Thomson model was there, but Thomson was actually, he was telling that like watermelon model.
Water pudding model. Water pudding.
Yeah, that's completely like different. అంటే ఆయన ఏం చెప్పాడంటే ఎలక్ట్రాన్స్ అక్కడక్కడ స్కాటర్ అయి ఉంటాయని చెప్పాడు, లైక్ సీడ్స్ లాగా. బట్ Rutherford is the only one, like he mentioned that nucleus exists, which is actually confined in a small region with a positive charge. And you can see he also determined these values. Diameter of the nuclear atom 10 power minus 10 meter. Radius of the atom is 10 power minus 15 meter. These are the very important values to remember. Diameter is, this is greater than this. You remember that negative sign is less, means this is greater. 10 power minus 10 is the diameter, 10 power minus 15 is a radius. And one thing we want to here, the one more important concept that you that I want to bring your attention: impact parameter. There is a definition we have. We don't have much about this in the syllabus. This is called impact parameter. Impact parameter. So what is that we're going to discuss now? So impact parameter, you can see it. I'm going to define it. See, can you see that? How the alpha particle is going? So the impact parameter is the distance between the the center axis, from the center axis to the path that alpha particle travel. So this is the distance between the center axis of the atom to the path that alpha particle went on. This distance is called impact parameter. Very important bit, 4 marks. Impact parameter, which is indicated by B. Okay. So now you understand this impact parameter. I'm going to show you something else now. See, it's not hitting the nucleus. Did you able to see that, students? Manaku డైరెక్ట్లీగా మనకు న్యూక్లియస్ దగ్గరికి వెళ్ళాలి, సెంటర్ మధ్యలోకి వెళ్తుందా? It's not going. It's going away. See, the alpha particles are not hitting the nucleus. They are deviating from the center of the nucleus. So in this case, what happened? Tell me. See, this is the impact factor parameter is 0. In this case, impact parameter is 0. Did you understand what is impact parameter now, students? Did you understand what is impact parameter? One of you respond. Give your response. Upender, are you there, Upender? So impact parameter is 0 only when the alpha particle directly hit the nucleus. In other cases, it didn't deviate, right? It is a distance between the center axis, atom axis to the axis, the path which alpha particle travel. So in this case, why it was actually, tell me. So this was here. It become a compound when it directly interact with the the gold ball atom. Simply what happened? Tell me. The compound atom, it becomes like more bigger. Compound nucleus formation. So Rutherford scattering, I mean, it's just basic. I think I have a class now. I don't want to continue. So tomorrow I'm going to close this one and start the rotation motion. So the mechanics part, first part is over. The second part is actually rotation motion, moment of inertia, rotation motion. We're going to discuss it. Yeah, any doubts for today class? Students? Students? Mute lo
Yes, sir.
Oh, unmute avatledha meedi? I think it should be, right? Anyway, yeah. So I think the class is over for today. I think, did you finish your attendance today?
Yes, sir.
Yes, sir.
Okay. So thank you so much for attending the first class in this new year.
Have a nice day.
So hope that you will have a bright future, and we hope that you will be, expel your knowledge and you will be like number one.
Thank you, sir.
All the best, Nana. Thank you so much. Have a
Thank you,
wonderful
sir.
closing the session.
Okay, sir. Bye.
Thank you.